For centuries, humans believed that our world was at the center of the universe. But then we learned that the sun and planets did not revolve around the Earth. Eventually, we also realized that even our sun, though the center of our solar system, was not the center of the universe. Instead, it was just an average star among the billions of stars in our galaxy. Until a century ago, we also thought the Milky Way was the only galaxy in the cosmos, which again was not the case. Today, astronomers believe there are 2 trillion galaxies in the observable universe. So, when did we learn about the bigger picture of the universe? Do we have a particular date that marked the birth of modern cosmology? The answer is yes. January 1st, 1925 was the day we discovered the universe as it truly is. But what exactly happened on this day that changed our understanding of the universe? To have an answer to this, let's travel back in time to the early 20th century. At this time, pinwheel-like structures in the sky, better known as spiral nebulae, had intrigued most astronomers. Many observers have documented these structures, and the most famous of all these was the Andromeda Nebula. It was easily visible to the naked eye at night, making it one of the most prominent spiral structures. While some researchers speculated these structures to be island universes, which are vast and distant systems of stars comparable to our Milky Way, many believe them to be small, nearby clouds of gas and dust. However, the contradiction between the 2 prevailing ideas was so intense that it led to the famous 1920 Great Debate between the astronomers Harlow Shapley and Herbert Curtis. Shapley believed that the spiral nebulae were relatively small and lay within the outskirts of the Milky Way. On the other hand, Curtis firmly supported the fact that they were large and distant, independent galaxies. Sadly, no conclusion was obtained from the debate as it ended with an unsatisfying draw. So what was next on the cards? The answer is the work of Edwin Hubble. By 1919, Hubble had established himself as one of the most patient and meticulous observers at Mount Wilson Observatory in California, which hosted the 100-inch Hooker telescope, the biggest in the world at that time. Also, by the same time, Vesto Slipher, one of the unsung heroes of modern cosmology, had found that many of the spiral nebulae were moving away from us at high velocities, far more than those of any known stars. While analyzing the peculiar redshift velocities of the nebulae, Slipher was convinced that the spirals must be independent systems driven by unknown mechanisms and were not a part of the Milky Way. But unfortunately, to prove his interpretation, Slipher needed a giant telescope to which he didn't have access. Although Hubble had access to the telescope required to verify Slipher's speculations, he was always cautious regarding theory and interpretation, so he preferred to wait until he could find another convincing hint that could prove or disprove the existing theories. And this is when another piece of the puzzle fell into place, and things got a kick. In 1922, Swedish astronomer K. Lundmark observed some strange objects in the arms of the spiral nebula M33 that changed their brightness. Following this, even John Duncan at Mount Wilson spotted some dots of light that grew fainter and brighter in the same nebula. But what were these fluctuating objects? Were they some variable stars similar to the ones we have in our Milky Way? Although there were still many speculations, Hubble sensed the possibility of a breakthrough and geared up his efforts to solve the mystery. He spent long nights working in the observatory. He precisely guided the movements of the mount of the Hooker telescope to cancel out Earth's rotations. Eventually, his efforts paid off, and highly detailed, long-exposure images of the Andromeda Nebula were obtained. These images resolved the nebula into several luminous points that didn't resemble a smear of gas, but looked like a vast hive of stars. These images motivated Hubble to dive further, and he started spying on a lone Cepheid variable star in one of Andromeda's arms. The star followed a 31-day cycle, growing from being brighter to dimmer. Now, Cephids are known as standard candles because of their well-defined luminosities. In 1908, Leavitt found that Cephids with longer periods are intrinsically more luminous than those with shorter periods. She gave a simple period luminosity relationship that could further be used to calculate the star's distance from the observer. So, following the same relationship, Hubble deduced the distance of the Andromeda Nebula from the Earth. Although his estimate was 930,000 light-years, less than half of the currently accepted distance of Andromeda, it was still a shockingly large number at that time. It established Andromeda as one of the brightest and closest spiral nebulae, lying widely outside the boundary of the Milky Way. Hubble's calculations concluded that the spiral nebulae were not some dust clouds. Rather, they were other galaxies, and our Milky Way was just one of them in this vast universe. But still, the story was far from over. As extra cautious as Hubble was, he wanted to have more evidence. So by the following February, he uncovered a possible second Cephid in Andromeda, Cephid variables in M33, and 3 other nebulae to make his calculations sturdy and reliable. However, despite his excitement at the Andromeda findings, Hubble was still reluctant to publish his results. He knew that not all of his fellow astronomers would happily accept the existence of other galaxies. It made him worry that he might end up looking like a fool. Moreover, at the same time, another astronomer named Adrian von Manen at Mount Wilson claimed that he had observed some spiral nebulae rotating extremely fast, which is possible only if they were relatively small and existed nearby. But soon, Hubble re-examined his colleagues' photographic plates and declared that the large rotations arose from obscure systematic errors. Soon, excerpts from Hubble's discovery leaked to the media. The first public announcement of such an astronomical breakthrough of the past 3 centuries ran as a small story in the New York Times on November 23, 1924. Still, Hubble was hesitant to a formal publication. But after a long series of persuasion by noted people, Hubble's discovery got a sensational public reveal on January 1, 1925. Hubble remained isolated at Mount Wilson while astronomer Henry Russell read his revolutionary paper about the existence of other galaxies in the universe. Nevertheless, one must also acknowledge that it was Shapley, not Hubble, who suggested that astronomers call the external star systems galaxies. In contrast, Hubble forever called the objects by the archaic name extragalactic nebulae. Hubble's paper not only ended the great debate and made him share the Best Paper Prize, but also introduced the world to modern cosmology. A single paper suddenly increased the size of the known universe by a staggering factor of 100,000. And this is how a new picture of the universe was born in front of us.